So how close are you to getting some sort of well, a Raspberry Pi hooked up to the chimp? Or because I've now got the WebSocket GPIO thing running where I can set a few pins.
Okay.
High or low remotely. So it's and it's available as a Docker container, which is uploaded. So for instance, if you happen to use that Raspberry Pi 4 that I know you've got, we could probably make an LED flash or something remotely.
So you mean we'll be able to get a Raspberry Pi connected to the internet and let people through a website control the computer?
Toggle some pins, yeah, and
then we can connect that Raspberry Pi to a chimp's head.
Yes.
Then anyone in the world can scare the bejesus out of us.
Yes. Yeah. But we'll just start with an LED, and that'll do. I have to open up a port on the firewall, but so the way it runs is the software on the Raspberry Pi connects out to a server somewhere else, but we could do it all internally on your network first. It just depends if it's not too late to try that tonight. Are you up for it? It was a bit late. You're muted. Is that because you're saying, no way am I doing that tonight?
We could try, but I've got a bit of a hard deadline to leave to pick up Carmen from friend's house at about 10 o'clock. Okay, all right then. Do you think you can hook up an LED to the Raspberry Pi on GPIO pins 7, 8, 9, or 10? Oh, LEDs, excellent. Right, that'll do. Yeah. Which colour? I'm feeling really organised. Red if we're, you know, showing danger. Red? But there's blue ones. Okay. Really? I'll go with whatever. It's a dealer's choice. Go for it. Oh yeah, don't forget the resistor, like Rob's just said.
Do you want me to set up Docker on here?
Yeah, if you got it accessible and it's going to run reasonably easy for you. Are you all on the same network there? I assume, since well, we're talking to each other. So. Okay, so I've got that. Cool, excellent. What pin did you want? Pin 7, GPIO 7, which I don't know. I'd have to look at the pin outs. Is that ground? Yeah, third one down. Yeah, that's pin 6. 2, 3, 4, 5, 6, and 7. Yep. And 7. And 7 is GPIO 4. Only because I've got those pins hard coded into that app. Can you stick it on GPIO 7, which is pin 26? Sorry about that. Oh no, all the way down there? Yeah, let me just double check something. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, that's the one. And where's the nearest ground pin? The nearest ground is 25. Ooh, so, brilliant. Yeah. I'm surprisingly excited by that. Yeah, yeah.
So I think I've got this up and running on Docker.
Cool, right.
Bear in mind, I only used Docker for the first time last week.
And Bob, I did use a 330 ohm, funnily enough.
Excellent. Paul, so can you, in the chat, I put a Docker pull command you need to execute?
Yep, done that. I've got it up and running in Docker desktop.
Excellent. I'll give you the actual next command to run. So Paul, this is the command for you to run as soon as I. So this is going to This is going to open a WebSocket server on your machine. Are you on a PC or a Mac, Paul?
He's on a PC.
Yeah.
Okay.
Cool. I've got it running in Docker desktop already. Should I stop it first?
What, the WS Cat thing? Yeah, because we need to give it the port numbers and things like that. So yeah, you might need to Control-C, kill it. That should be fine.
This is a Raspberry Pi 3, by the way.
Okay. Well, it should work as long as you've got Docker installed. The only reason I mentioned that other Raspberry Pi 4 is that I know it's already got Docker installed.
Yes, listing on 12.12.1.
Yeah. Cool. Excellent. Right. So, can you figure out the IP address of your machine, please, Paul? In PowerShell run IP config, something like that. Because Matt's going to need that bit of info in a minute. You can tell me your IP, and I'll write up. I'll form a command that's got to be used.
Bear with me. Okay. Oh.
This is fun.
Yeah. Well, if it works.
Okay, so I've got 172.21.144.1.
I think that's probably right. You've probably got another one in like the 192.168 range on your actual.
Oh, you want the local one?
Yeah. So that one you gave me won't be routable from outside.
192.168.1.14.
Seems brilliant. Thank you.
The local one.
Right, this one I need to. So Matt, once you're able to shell into the Pi.
Oh, yeah.
Well, and once you've got Docker installed, it's getting Docker installed, I think is. Can't remember what the process is for that.
I'm using the SD card from the Mantis project, so it'll already have.
Oh, okay, that's great. Yeah, that's excellent.
Thing.
Do you want me to do this one as well?
No, your one should be ready now. That one should just be. Hopefully, it'll be connected to from the Pi.
So lead us through this. What's the path then? You're coming through the network via Docker.
I'm not actually. This is all running just within your network for now. So you've got running on your machine a WebSocket listener, a WebSocket server, and then on the Pi we're going to run a container which is going to connect to your server. So that's why I needed your IP address for a command that Matt's going to run, and then I'll have some stuff for you to paste into the server. So it can send a bit of JSON to the Pi, and the Pi will then go, oh, it's essentially the JSON is all the pin numbers and the values they should be set to, and then it will turn on some pins for up to a second and then turn them off again.
Cool. Very cool.
Can you read that?
No, it's a bit blurry for me. That's better. Oh, we are in the Pi. Okay, Matt, in the chat, I pasted the Docker pull command for you to run.
Bye, John.
Ta-da. Bye.
Cheerio.
No, Docker pull. I've pasted it into the chat for you. Yeah. You should be able to copy and paste it.
Another language, obviously.
Yeah. Do sudo space bang bang. Enter.
So this is Linux, that is,
yeah.
Is it having trouble reaching the internet?
I didn't know that one. Bang bang is run the previous command on a sudo.
Yeah, yeah. I think you could do bang and then a number to like sort of hit a particular offset command, but bang bang does the most recent one.
Cool.
Oh, it's downloading. That's good. Once that's done, Matt, the next command is No, that's not it. Sorry. The next command will be pasted into chat momentarily. Right, there's the command to run. Oh, you'll need to put sudo in front of it again. But yeah, so I advise you, I'd copy and paste it, and then right click in your terminal window was probably the paste command.
This window is double geeky now, isn't it? Maybe even triple geeky. It's OBS, so there's an picture-in-picture.
Yeah.
Doing some Raspberry Pi stuff and watching the 3D printing all at the same time.
So
this
Paul,
might be a first.
Paul, on your screen, hopefully you'll see something where Matt runs a command where it says client connected or words to that effect.
All right, firewall is off.
Cool. Maybe kill that WS cat you had running and start again. So you should be able to do Control-C on it. Then launch it again.
So I kill the what?
You know the Docker process you had running on the command line. If you do Control-C at the command line, it should kill that container for you.
All right, it's up and running.
Cool. Says listening. So if Paul, you're once listening, Matt, perhaps you could kill the process on the Pi and start it again.
You changed my thing to Paul the Impaler.
Ages ago, right near the beginning.
I've just noticed it said Paul the Impaler.
Yeah.
When Paul was first on Zoom, he was still as Matt Mapleston, so I changed his name to Paul the Impaler. Because I just noticed.
Okay, so unfortunately, it looks like that's not working for us. So there's some sort of problem making the connection out.
You've got to send this to the company, surely.
Yeah, on for a second, then off again. So one PC running Docker and WSCat to an Raspberry Pi running Docker with a Docker image to put an LED on. I mean, you could say it's an over-engineered solution.
But now we can turn the monkey on.
Yes. When we figure out what to wire it up to, we can, Right now we've got 4 lots of I/O we can mess around with, but we can make all the GPIO accessible.
So there's the Docker command running on this.
Yeah.
And there's stuff in the chat. So the thing that solved it was that net
No.
Wasn't it?
No, so I found that the Windows Defender, when you go through the system tray and it turns it off, it actually only turns it off for private networks, not for the public networks. So when I went through the control panel, then it was going, "Oh, do you want to turn off the public networks?" I said, yes. What the fuck does the phrase "turn off" mean to you?
Okay, right. So it was Windows' fault. That's never happened before.
Yeah, so I don't know if that netsh command might be causing some other sort of trouble. I hope not, but it probably didn't have any effect since something was already listening on that port.
So what's Paul running?
He's
is it the Yanzi networks?
Yes. Yeah, so that's there's a command out there called WSCat, which is for just catting WebSockets, but you can actually write to the WebSocket as well. So it's quite a useful command for this sort of debugging. And then Paul's been pasting some JSON text over there, and then that JSON gets passed on the Raspberry Pi, and then.
And is that format set by the WSCat?
No, WSCat is just sending through messages which consist of some, well, actually just consist of some buffers of data, some arrays of bytes. Those arrays of bytes happen to be like ASCII or UTF-8 strings. And
your motor WS controller is set up for that message, which is why you're asking Paul to send that particular set.
Yeah, for every WebSocket message that reaches WS controller, motor WS controller, it looks at the very first byte and says, oh, is that an open curly bracket? And if it is, then it attempts to pass the whole thing as some JSON, and then just cracks on setting those pins high. So important things on that command that you've run on the Pi map, there's that environment variable there, command_URL. So you need to set that to be the IP address or the host and the port that the host is listening to. Okay. And then on Paul's machine, Paul, that command you've been running, the -L bit is an argument to the WSCat command, which tells the WSCat program to listen on a particular port. But then the -P bit is an argument to Docker, which says, hey, do some port forwarding from port 8080 on, or basically expose port 8080, it says, for this container, or as port 8080 on the host. So there's not anything particularly clever Docker-wise, but you just need to get used to running it a couple of times.
Okay, so it's that Docker run that you sent at 9:17 that Paul's running, because that's got the 8080 in there.
Yeah.
This feels like a blog post in the making.
Hey, there we are. Or just be like, how did we make these things run?
Yeah.
I suppose. In which case, I should package up the code for you as well, so that you can post the code along with it. It's pretty basic, but yeah, it's
therefore accessible.
Yes.
Do you have another? Hang on, let me change my camera.
But you could, if you put now another LED on, you could put, because currently that software running on the Pi will write to port pins 7, 8, 9, and 10. GPIO pins 7, 8, 9.
Cool. You want me to do it
now? Paul, do you feel happy? I'll give you a different command, Paul.
Pin 7 to 1.
Yeah, here I'll send it over to you now. Right. Use this next command, Paul. That will set pin 7 to 1. Can't see the LED, Matt.
Wrong way. It's reversed.
Yay!
Right. 4 LEDs.
Yes.
Is that 4 out of 4?
Yeah, 4 out of 4.
Oh yeah, there we go. So what is it that it's that's interpreting this on the Raspberry Pi side? So what's it like interpreting the JSON?
Oh, so it's a node. It's JavaScript, or it starts off as TypeScript. So if you got VS Code on that machine, Matt, that Paul's using,
you think so? If you choose type, press the Windows key and type code, it should come up.
So if you git clone that repository I posted, you'll be able. I can then point you at the code and explain what's happening. And then I will probably need to go away. I'll have to call it a night then. Like the code myself to remind myself what it does.
Wasn't it fortuitous we had Docker on a Raspberry Pi ready to go?
Yeah, it was, wasn't it? It did mean that we didn't have to worry about installing dependencies on the Pi. So you could argue it's overkill that we have it on there at all, but it did get us going quite quickly.
See, that's the wonder of the geekery. We've got the software, the electronic components.
Well, that's what I was trying to.
And the talent.
I don't know about that. I think if we were talented, we'd have got there a bit quicker. I think the whole time you were dissecting the chimp, I was trying to make this work. And then turned out, I don't know if you can see on my, but there's a battery pack that needed to feed the which I forgot to turn the power on.
Okay, talent was a bit of a strong word there.
Yeah. So I forgot stuff.
That's cool. So yeah, so okay. No, I don't. Yeah, I mean, I don't want to go into the code right now, but I mean, it's interesting to know though. It's
interesting to know that. So that's how it works. So there's something on the Raspberry Pi that's picking it up, JSON, and then just translating it into the breadboard.
Yes, yeah, pretty much. And yeah, there's basically 3 files. Like one file initializes things, the next file does the listening on the WebSocket, and then the last file takes that string message that comes from the server that you're running, and then converts it into JSON, just so it can then more easily examine what's in that data structure. It didn't need to do it as JSON, and just chose to do it that way. We could have done it by sort of walking some sort of text, or come up with any sort of protocol really. We could have sent just a number and have bit fields in there that corresponded to our outputs.
Yeah.
So it's quite a verbose protocol really. But my thinking was, oh yeah, and I set it up so that every
it's just a McDonald's delivered.
But every time we set a pin high, I've got code in it to then set it low again after 1 second. So because I was originally controlling motors with it, I wanted to make sure that I didn't send a command to turn on a motor and then lose communication.
I don't know if I'd want the temptation.
Oh. Is that your screen's very blurry for me, Matt?
Yeah, it is.
That's it. So look at index first of all.
Oops. So I'm just trying to make it bigger.
You can probably just maximize, yeah. So it's index. This is the startup file, and what it's doing, it's just printing out some stuff. That line 11, it's just where it checks that we've set the command URL environment variable. So we're not using any libraries to do all the environment checking. And then if you haven't set the environment variable, it exits. Then it calls a command init. So line 3, you'll see that we import a function called init as command init from the command file. So now if you look at command.ts, in there, you'll see there's an init function on line 32.
Yeah.
And in this guy goes and starts making that WebSocket connection. So on, it does a little bit of checking to make sure init hasn't been called twice on line 36. But line 46 makes a connection and then sets up lines 49 onwards, sets up some handlers. So line 50 is where it says, right, when I get a message, I'm going to run my message handler. Your message handler is on line 28, which calls IO message handler. And so up in your imports at the top, we see that we're importing the IO message handler function from the io.ts file. And this is where we do some sort of basic stuff. So it starts on line 31, really. Up above it, I did a load of stuff so I could run it on the PC and with some mock pins. So I mocked out some pins. So I basically stuck all the pins I've got available in a map. It's a bit more complicated than it needs to be, but it's because I was trying to run stuff on the PC to prove what I was doing. And so, yeah, on line 33, I look at the data that's been sent, and then I pass it to JSON, and I've logged out a few bits to figure out what's going on. And then if there's an array called write GPIO in that JSON, then I clear a timeout if there's already a timeout pending, and then I go through each of the objects in the array from the JSON, and I set the pin values accordingly.
Nice.
And that's it. And then, yeah, so then I set a timeout on line 55.
So when you say you set the pin values, how are you doing that bit?
Okay. Yeah, so line 48, sorry. Line 48, the GPIO library we're using provides a write sync thing. So I'm doing a synchronous write. I'm making a change to the file system, or it's not. It's sort of it's a virtual, what to call it. I can't remember the terminology used, but essentially it's a file system like way, like it's a Unix bit where the device is exposed at a file system, on the file system. And yeah, so I'm writing to that location synchronously. But GPIO is a library. So line 1, we import an object, really, GPIO from the on-off library. And so that's the library we're making use of. So if you were to search npm space on-off, all one word, you'll find the library we use for that. And they might have all the write-up in npm, or they normally have a link on the right-hand side to the page or the website for that particular library as well. So we can do things where we can, I think on-off has things where it could do interrupt detection as well. So it could raise events when it sees an edge on a GPIO pin if you wanted to. So the chimp might have something to tell it, like it's detected something. I think you said maybe it had some sensors on it. So could it detect if something's close to it? If it can, and we can get a change, an edge on an IO pin, we could use this library to detect it. But then equally, there's a few different libraries now. Yeah, so that's.
So it's any. That's really cool. Any Linux, well.
Let me.
So it's Raspberry Pi, BeagleBones.
Yeah. So if you are in the directory where you've checked out the stuff to, this that I'm posting now is the build command. So after the -t on the build command line, that's the tag for your image. So Dan Watford is my repository on Docker Hub. But if you've got a log on Docker Hub, you put your own one there, and then you can push and then you do Docker push. In my case, push. You then push the image up to Docker Hub, and then you pull it back down again, and then run it on the Raspberry Pi. That can take a while though, when you're sort of going around the development cycle quite often. So it might be better to then run a local Docker registry on your network, which we've done. So we can do that again if need be.
That's awesome.
Very cool.
So I was messing around with it to drive my motors on this, just to make them go forward and back. And then I haven't done anything else with it. So I just thought that's what we could use for controlling GPIO. But I'm sure there's got to be other libraries out there that have already packaged up something nice, listens on a network and then enables you to do it. But the thing I quite like about this approach is actually the software running on the Raspberry Pi calls out to a server running somewhere else. So we don't have to worry about what IP address the Raspberry Pi's got. So we could sort of stick an SD card in a Raspberry Pi with everything and then send it off, and it will get a random IP address with DHCP. And it's the WebSocket host that we have to worry about knowing where it is.
Okay.
I'm going to call it a night, guys. Thank
Lovely.
you very much.
Indeed.
Awesome, Dan. Thank you very much for your time this evening.
Very cool.
That's very welcome. Hopefully I'll be with you next time. And yeah. All right. See you later. Good evening.
Bye.
Cheerio. Bye-bye.
Sorry, I missed the end bit where you got it working. Did it?
Yeah. Do you want to see?
Yeah.
Can you? So Paul's computer could be anywhere in the world, and it communicates to this little computer, Raspberry Pi. And so Paul can just send basically some text to the IP address of this and turn on lots of things, but at the moment just these LEDs. But that could be turning on the blink of a monkey, or it could be triggering a scream of a monkey. It's quite monkey related at the moment.
That's connected to Wi-Fi.
Basically, the board is connected to a Raspberry Pi.
Got what?
The circuit board.
Yeah.
The monkey.
No, this circuit board is a computer you can buy for 30-40 quid. The Raspberry Pi 3.
Oh, okay.
But
Dan was saying that you can control the monkey.
Yeah, so that big circuit board that I pulled out the monkey, I'd replace with the Raspberry Pi. Because it does have Wi-Fi on it.
Oh my god!
So Paul on his computer anywhere, given the right connection, could control the monkey from anywhere. If we allowed that, probably wouldn't, knowing Paul.
That's awesome.
It is amazing. Everything. If you don't realise you can do it, it is magic, isn't it? And so you could even write a little app for a phone or a web page. It would be a web page with some buttons on there and maybe a webcam pointed at the monkey. So anyone, anywhere, could connect to the Geekery's chimp and control it.
Yeah,
that'd be quite cool.
Yeah, absolutely.
So could you connect that to any electrical type? So I'm just trying to think.
We could connect the chimp to a news feed, and every time a new story comes on, the chimp could read the news with its mouth moving appropriately, for example, or it could read out the Bitcoin price. Not that I've got any.
But does that mean that you can connect any the Raspberry Pi to any sort of like mechanical, electrical thing and control it?
Yes, absolutely. Via relays, for example. A relay is like a big tap with a massive water pipe going through it, controlled by a little pipe. Because Raspberry Pi can't take lots of electrical power, so it's kind of weak signals, but you can use those weak signals to control big taps with big signals and big voltages and that kind of thing.
I was remembering the world's first webcam. I remember. Do you remember hearing about that? It was. I think it was the late 90s or early 90s, and it was in Cambridge University, and it was somebody who got really bored of walking downstairs to check if there was coffee.
Yes.
And so they set up a webcam on the filter coffee machine, so they would know if there was anything in there. Which all things like I think Christ, some small tiny little thing like that became what's it used by now? From video conferencing of world leaders to porn. I was about to say like the lot.
It all starts with porn, really.
It does. Well, it starts with coffee, and then
coffee,
it goes on to porn. Let's get your priorities right.
And I think it was someone in MIT that did some kind of link to a Coke machine to know if there was Coke still in there.
Oh, really? Fantastic.
For early use of the internet, or at least networks. Very cool.
I guess it's playing about with stuff like that.
Oh god, it's just playing around and
playing about,
dreaming.
That's what leads to ideas, though. That's what the possibilities with that is ridiculous.
Well, it's just knowing the little bits of what you can do and then putting them together in new ways, exciting ways, or pointless ways, like that chimp.